Hi everyone. So today we'll be looking at contrastive learning for prompt-based few shot language learners. So in this paper they use few shot language learners which are prompt-based, and they also use a contrastive learning framework with a novel data augmentation method. So this is a very good illustration of their method, right? So they have a language model, and they present it with prompts. So the input is basically converted into a prompt, which usually has a mask, and this mask is supposed to be predicted by the language model. So here, for example, the story is not worth reading is the input, and you have a sentiment which is associated with the input. So here it would be a negative sentiment, right? And then you convert this into a prompt by applying a template, and the prompt would now look like the input, as well as a truly blank one where the language model is supposed to predict a token which maps into a negative label space, right? So this is a prompt, and recently it's been shown that adding demonstrations along with your prompt boosts the performance of the language model. So here they have a positive and a negative example, right? So this is a great one is a positive demonstration, and a terrible one is a negative demonstration. So they append that along with the prompt and present that to the language model. So now you can see that in sentence one, the input is the story is not worth reading. And sentence two as well, the input is the same. The story is not worth reading. But now, how you convert that into a prompt is different because the template which is applied is different. Now, here the template is, I think it is, instead of a truly blank, right? I think it is mask. So and then the demonstrations are also different. The positive demonstration is about the flight, and the negative demonstration is about a show, right? So you can play around with different templates as well as different demonstrations to, they call this different views of the same data. And this is basically data augmentation, right? For the same input, you can generate multiple inputs by playing around with your templates as well as the demonstrations. So in contrastive learning framework, examples which are similar are clustered together, and examples which belong to different classes are clustered far apart, right? So here sentence one and sentence two are just the same. So they belong to the same class, and they need to be clustered. Their representations need to be clustered together. Whereas if you compare sentence zero and either of these sentences, they are from two different classes, right? One, the sentence zero is Professor Ronaldo won Nobel Prize. It's something positive, right? So this is a positive sentiment. So basically, this sentence zero and sentence one would form a negative pair, with each sentence belonging to different class. And you have sentence one and maybe sentence two or sentence three. They form a positive pair because both of them belong to the same class, right? So here what they do is, along with the language modeling objective, which is a cross entropy loss, right? They also add the supervised contrastive learning framework loss, right? So that's what they do. So for each batch, they add both MLM objective, which is a cross entropy loss, as well as the supervised contrastive loss. That becomes your total loss. So here they show their method where they have a language model. I believe they work with Roberta base, and then they have a training set. Now in their training set, they have just around like 16 examples, and that's where the few shot learning comes into play. And then they randomly sample either the demonstrations, you'll see that later. So here, what they do is they sample from the training set a sentence and a class, right? Because this is a supervised training set. And then they sample two demonstrations, and they get two different views of the sentence called input one and input two, depending on which demonstration is sampled, right? Is which demonstration is concatenated. And then to learn from the MLM laws, they basically compute the cross entropy of input one, right? The output of the language model when it is presented with input one. And they use that to update the weights of the language model. And after they update the weights, they use input two, right, to generate output two. And then now they have two different outputs. They basically, and they correspond to the same sentence. So this would be a positive pair example, right? So they then compute the supervised contrastive loss, and then they use that to update the parameters. So they apply both the MLM loss as well as the supervised contrastive loss. So that's what they do in their method. And their baseline is from another paper, the LMBFF paper. Um, and they pick the templates as well from the LMBFF paper, as well as demonstrations. And they compare this with they find that this method basically performs better either when you have demonstrations. These are the extra examples we saw for both the positive and the negative class, as well as when you don't have demonstrations. Even then, having this contrastive loss is leading to better performance. And then they compare, so their augmentation method involves sampling different templates and sampling different demonstrations. They compare these with other data augmentation techniques such as synonym replacement or random insertion, random swap, and random deletion. And for most of the data sets, they find that the data augmentation method which they propose by sampling different templates and demonstrations performs better. And then they so you have a choice of fixing the demonstrations and varying the templates, or fixing the templates, varying the demonstrations, or varying both the demonstrations and the templates. And they see that for some tasks you have fixing demonstrations helps, and for some other tasks fixing the templates helps, and in some tasks varying both of them leads to better performance. So the main takeaway of this paper is adding this contrastive learning framework, the contrastive loss, along with the cross entropy loss, and having good data augmentation techniques using templates as well as demonstrations. They can basically boost the performance of prompt-based language learners, and they outperform the state of the art in few tasks.